All right, gang, we'll keep things rolling here. Our next presenter is Joseph Buschman from Victaulic. What was really helpful is last week we had a team call for all those presenting today, and Joe and Luciano were like, "Oh, you're doing this? What are you talking about?" And Luciano was going first, so he said, "I'm talking about this, that, and this." And Joe's like, "That's kind of what I was going to talk about." So they were able to collaborate and modify the presentation here for this afternoon to hopefully continue to add a little different value to what would have just been very repetitive. But we're excited to have him here. Victaulic has been an associate member of the Alliance for a long time, and a great partner, and always willing to step up when called upon. So I'll turn the floor over to you. It's all yours.
All right, so once again, Joe Buschman, the balancing control specialist for Victaulic. Luciano's in town. The main product line that I deal with as a balancing control specialist is Turin Anderson. I am available to do trainings on a loop and that sort of thing. We could talk about that later if you're interested more. But today we're going to be talking about domestic hot water systems and the importance of having recirculation. Some of this will be repetitive. The Victaulic guy leave. Yeah, good. I would never talk bad about somebody else's valve to their face. But we can talk about it now. So just an overall summary. It's going to be quick. I know you guys have seen a lot of PowerPoints today, so I'll make this brief. And if you do need more information, just chase me down afterwards and we can talk more about it. But we'll talk about recirculation in systems. We'll talk about that new thermal valve that we are offering. And then we'll get into some other balancing options that we also offer for domestic water systems. So first, we've got an illustration here of a standard open domestic water system. With this system not having recirculation involved, we see temperature instability. So I think we've all sat at a hotel, wait for the water to heat up. There are plenty of other commercial buildings where we see the same issues occur. We waste water and pumping energy, and then we also have risk to drinking water that we'll touch on very briefly as well. When we look at waste in circuits without recirculation, we see 1/3 coming from the water being wasted or going down the drain, and 2/3 coming from the pumping energy. Systems without recirculation increase about 15% of your total consumption. And then there's a fact about how much water we are wasting in the US annually without having recirculation lines. So this talks very briefly about pipe size and some of the delays we see. We've got your toilet sink and a shower, obviously 1/2 inch, 3/4, and 1 inch are very common lines we see. And they say for the average human being, 8 seconds is considered to be an uncomfortable amount of time to wait for water to heat up, which seems very short, but I guess we are a very patient group. So I know the collective guy touched on Legionella. I don't know much about Legionella. I don't know if you guys face this type of thing in your daily industry. I thought I'd touch on it. It is important. Apparently 10,000 cases occur in the US every year. And that happens in commercial buildings all over the country apparently. So this just touches on the temperature that we see Legionella occur at, and you see it starts at 70 degrees and works its way up to about 120, and then it starts to go away. And we'll see we can put an end to this with recirculation lines in our system. With that being said, this is an illustration we have of what that recirc line looks like. We got a pump on it. Essentially, it's coming off all the other hot water lines. I know you guys saw an illustration before that looks very similar to this one. Any questions on this? Not yet. All right. So when we get into the placement of our thermostatic circulation valves, and we'll touch on some of the feature and benefits of these very briefly in a little bit, but these therm valves, I believe, is it getting passed around right now? Yeah. So these therm valves go on the return piping of your recirculation line, and you set that thermometer on there to essentially maintain that temperature in your system. Much like the Fluffy guy, it's got that wax material in it. When it dips below the required temperature to that you're looking to maintain, the valve will open up, recirculate water through the system so that you can get hot water instantly in your system. We'll also touch on automatic balancing valves. You can do something very similar with those. So a new valve we're offering, it's fairly, the technology is fairly old. It's about 20 years old. These valves are used quite a bit over in Europe. However, it's new to the US because we now offer it in no lead. So it is a TA Therm 0. Passes all our certifications here in the US. So we got NSF and ANSI, 372 and NSF 61 approved. I do have a bunch of material on this. If you want to see more about these approvals. Looking at the valve a little more, the thermostatic valves for automatic balancing and domestic water systems. It has the ability to shut off easy temperature setting with that adjustment knob on the top, and then our static available static pressure is 116, max working temperature 194, and we have it in 1/2 inch and 3/4 inch sizes. And then what's getting passed around right now is what we consider our kit offering. It comes with extra ball valves because we need isolation, and it's fairly redundant, but that can be customized to a certain extent. Any questions on the valve right now? All right, we're getting through it here. Thermostatic circulation valve. Once again, easy to maintain. It contains less than 1% lead, which meets all the approvals that you'll see. Oh, and these are the 3 different offerings we have. So we have it with a thermometer, we have it with a plug in the middle, and then we have it with a PT port, depending on what you need required for your system. This just walks through a breakthrough of what the valve entails. The temperature gauge, the lug for identification tab at the top, temperature scale. It has a lockout. I think it's a 2.5 millimeter Allen key. And then the casting line there as well. So breakdown of the TA Therm 0 and what it would look like being installed in your system. If each of those branches had 3 sinks on them, it would be on that return recirculation line. As well as, you'd have some balancing valve in there as well. Flexible range, easy temperature adjustment, all that kind of stuff. Now we'll get into a few more of our domestic water balancing solutions, and he'll pass those around. We've got a new globe style balancing valve for domestic systems. It also has less than 1% lead. That's a little bit easier to balance with in comparison to our 78BL, which is our ball valve offering. I ran across a system a month or 2 ago where they went through and balanced with these ball valves, and they were really struggling with getting each area, or it was an apartment complex. They were struggling with getting each apartment to get water quick enough, or hot water quick enough. So we all know globe style valves are a little bit more precise and easy to balance with. That's now a new offering. However, we do have the ball valve. What's getting passed around right now is our 790. It's available in 1/2 inch, 2 inch. Its max working pressure is 400 PSI. Its temperature is -4 to 248. Stuff. We also have a 76X. It's our automatic balancing valve. I know we've talked about automatics. This is the 3rd time today. They all work the same. It's got a cartridge in there. This is the stainless valves for potable water systems, for domestic water systems. If you want, you can unscrew it and push the what's the word? The cartridge out. And you can kind of play with the cartridge if you want to see what that looks like as well. NSF 61 approved, offering a couple different sizes with a lot of flow rates. This is a breakdown of the domestic water kits that we offer now. The top one essentially has a ball valve in it. You guys are getting the 790 passed around right now. with a couple of extra ball valves. You've seen the therm valve, and then the last one is with our 76X. Maybe just some of the features and benefits. One of the last things I like to touch on, many of you have seen or heard about the Victaulic 4.1s, but if you haven't, we have this 4.1s where we are now moving to more modular solutions. With these modular solutions, we offer pump drops, PRV stations, air handling unit drops, and headers. And essentially, to kind of relate this back to you guys in the balancing world, these pump drops are offered with large diameter balancing valves. If the engineer requires globe style balancing valves near the pump. And then we also have balancing valves included in our AHU drops, which essentially is just a big coil kit for an AHU. And I'll show you a picture of what those look like. A couple different flavors of our air handling unit drops. We will customize them kind of for you, but we have single coil and double coil setups. Some guys even have triple coils. And we've got a new version that fits in a doghouse on an AHU. It's much more compact. It's just looking to streamline your process, not looking to take jobs from anybody. That's all. It's a lot of group product. One of the great features about these AHU drops is it's got a swing arm on it. They're essentially all of these couplings here are flexible, and they're able to move around and make for an easy fit to your air handling unit. I know sometimes, most times, those supply and return lines coming out of the AHU are never in the right spot. So we made a flexible joint to reach those. This is what they look like shipped. It's kind of a mock-up next to a crawl unit. Great for data centers, very redundant, get you what you need. Any questions on AHU drops? All right. VIPDs, pump drops, or vibration isolation pump drops. We offer them with balancing valves. Very streamlined products, make them different flavors for different pumps. Kind of what they look like themselves. And I know I went pretty quick, but it was all very similar to the presentations you've seen before, so I'm trying to value your time. Any questions on any of that? Yep.
Those automatic temperature control valves
Yes, sir.
that you put on there with all those valves before and after, is there that much maintenance that's got to be done on them? Or they pull over?
Nope. We just know, in certain parts of the country, they require, balancing valves to be, or excuse me, those ball valves to be on there, for isolation purposes around a valve like this. I don't believe there's much maintenance required at all. It's just how engineers, work. I know this is a bigger product on the East Coast for us. However, it's working its way across the country. And do you guys use these a lot or see them a lot? Or is there a need for them more often? In Wisconsin, let's just talk about Wisconsin.
The caveat of a lot, yes, you did get used.
Okay.
Should they get used more often? Probably on older buildings, actually. Stuff
Yeah.
that gets renovated a lot.
Okay. Whose valve are you using right now? Or what would be a common name for a thermal valve like this in the state of Wisconsin? Is it Caltherm? Who else would be a competitor?
Is ever the cheapest at the wholesale house?
Okay. All right. I appreciate it. Yeah.
Probably.
I'm learning about them as well, and I figured I'd pick
I
your
think
brain.
it's solver, right? The circuit solver, I forget who makes it.
Yeah, okay. All right.
It's not the cheapest, but our product, it does have two main advantages against that one, and we do have a very competitive price. The main point, we have the thermometer on the body, and the second one is the adjustability, that you can change whatever temperature you want. On this product that you mentioned is, you need to buy with the cartridge or the temperature that you want, and that's it. But if you go back one slide, no, the one that with the kits. I think it's good at just giving like a brief explanation about the overall advantage and disadvantage of each one, but manual balancing valve would be most of you work of adjusting all of the manual balancing valves in the job. So between the ball valve and the globe style is much easier. I think most of you saw that around the TA globe style. One of the other great advantages of using an automatic balancing valve, you can set the flow rate for all of your recirc lines. And that could be as low as a 0.33 GPM, so really low flow rate on the recirc line. So what that means is on the project, you can downsize the main return pipes because you can guarantee that you're only getting 0.33 GPMs. So that is one of advantage that we see some designers using that for, to be able to downsize the main return lines. And when you're looking at the most energy efficiency solution, it is definitely the third valve. The third valve, let's say you set at one temperature. If it's below that, the valve will open to allow the water to go back to the boiler. But if the water is above that temperature that you set, the valve will close. It doesn't make the sense for the water to go back to the boiler since you already have the temperature that you want. And when you're thinking about that in a cascade effect, many branches, many risers, the ones closer to the pump and boiler, we're gonna get hot quicker. So this one will close down and push the water further and keep pushing the water further, and all of the branches will get the right temperature. So it's important to think in this cascade effect. And also the therm valve, it is a proportional control because it's a metal expansion and contraction. So it's not like a solenoid valve that will open and close like 5 seconds. So it will slowly open and slowly close depending on the temperature. And also it's important to think on the therm valve. As soon as the valve fully closed and you don't have water passing through or very low water passing through, the water starts cooling down. So that makes the valve open again and kind of proportionally control that. That is basically how it works, and that's why it's the most energy efficiency solution.
I think it's the opposite. It's the ones furthest away, because it's not a research system.
Yeah.
So it's the valves that are in the line, they see that higher temperature, and they'll start to cool off, and then they'll close off to get closer.
I'm thinking about the beginning. So when you turn on the pump, if you have all the valves fully open, the ones that always get in the first hot water will be the one closer to the boiler. That was my thinking, not in the way that it operates long term.
It's at the end of the run, so you can find the hot water. The hot water is your recirculating, coming back. Thinking about this wrong.
It could be if they're using the points.
You're talking about branches versus individual fixtures.
Yeah, in the case that I'm thinking about is thinking all of your fixtures are closed. So the water go first to where it's easier to go. And that is the point. But it could be anyways, thinking about from the first to the last or from the last to the first. Both ways would be a proportional and a cascade effect, kind of moving that, all of that at once. And of course, all this is recirc lines. So it's normally 1/2 and 3/4 inch. The globe style or the first or the second option, it could also be installing branches or risers if you want to balance the whole supply, not the recirc line, but the supply side. It could also be installed on that.
What's the minimum flow you set on some of these?
For example, the flow limiting device, the automatic balancing valve, is a 0.33 GPMs. It is on the table.
The reason why I asked it is because we talked about it this morning, and at lunchtime, I got a call from a plumber. Was asking me questions about a research, how, apparently, and you, that research line has to be within 2 feet of a hand wash device. So I mean, and this is a nursing home, so it means every room going down, and he's got 3/4 inch circuits. 3/4 inch line on the return. How do you, if you had put .33 gallons in each, by each sink. You're gonna have a pretty large pump.
If you have a 3/4 inch, so this 3/4 inch could be the 0.33 or the 1/2 inch as well, the same
Yeah.
cartridge. But if you have the circuit setter, it is a ball valve style, the same as our 7/8 BL. So you could run a much higher flow than 0.33. If you look at this valve manufacturer submittal, they claim that the minimum flow rate that they can set is 0.5 GPM above the 0.33. But since being closer to the mechanical room, could be much more than 1/2 gallon
Yeah.
passing through
But
that
even
circuit.
putting something like that in isn't solve the issue neither.
0.33, it's much better than 0.5 or 1 gallon, or it
But
will
if you
solve
got
the problem.
15 If you have 15 sinks down that lane, and you got 4 lanes, that's a lot of gallons, just under these circumstances.
Depending on how it was designed, if the design was taking the consideration that you're gonna have a 0.33 GPM or 0.5 GPM in each recirc line, it worked the same way. But like I said, the best recommendation would be the therm valve. Yeah. My recommendation to your case, if you change that to a therm valve, you're not getting this overflow, because if you start
But you
getting
still
more.
gotta balance it somehow. Even if you put in a thermal valve, that'll shut it off when it reaches temperature, but you still gotta verify that they hit the flow somebody said he wanted to hit.
Yeah. But the therm valve would do that automatically. So you settle for the temperature that you want.
But not to a NIST compliant rating that's reportable to somebody and re-measurable to somebody else down the line, right? J. Cole comes walking through and says, show me that you're hitting this flow. How does he do that? He calls you up and you're gonna put your name on it and say, yeah, I guarantee it.
Yeah, the therm valve is a different concept. You balance through temperature, not through
That's the
flow
point.
rate. If the person is not understanding how the valve operates and is still asking for the flow, the way that you can do that.
But we have to explain it to a lawyer, right? Like, that's not the point.
Yeah,
The point is that somewhere on a piece of paper, it has to be measurable, it has to be repeatable.
you can measure the ultrasonic flow meter, not at the valve. We have one of the valves with a PT port point. One other way, if you want to measure flow rate, would be getting the circuit with an extra PT port. So for example, if you have this valve with one PT port at the body right here, you saw the option. If instead of a plain ball valve here, you install another PT port across the valve, you can measure the pressure drop. And on the submittal of this valve, you can find the CV.
Right.
So if you measure the delta P and you know the CV, you have the flow rate for the report.
Right.
But the difference is this valve is variable. So right now, when you're taking the measurement, it could be at 1 CV. 5 minutes later, at different temperature would be a different CV because this valve is always operating. It is kind of the same as an automatic balancing valve. An automatic balancing valve, you cannot measure. Oh, it's somewhere around. Oh, it's here. Automatic balancing valve, because of this cartridge, is a design of the valve.
Right.
Even if you put the 2 PT ports, you never know what is the CV of the cartridge. When you measure the delta P, you're just assuming that you have the right flow
The
rate.
max flow of that valve is rated at some temperature of water while it's running through that, right?
Yeah, a big range. The flow rate, it doesn't matter in that way, but yes.
So that's what I'm saying, you would have to measure that valve cold, know what the max flow rate was going through there, knowing that it would be less than that when the temperature increases.
Yeah, that could be a good way. But you still need to add an extra PT port. Would be the model with a PT port, and this valve would be a valve with a PT port union. We have that too. And measuring across the
That's
therm valve.
15 cents per lane. That's 7 cents.
Another option, if you want to take in a more precise measurement, if that is your concern, I would go with the globe style. Globe style is the one that most of you are used to in the day-to-day as well. The same as a TA valve, now is a lead-free. So just changing material of the body, but you have the most precise measurement on that. And balancing through the flow rate. But the same way as showers and taps or sinks start open up in the system, same thing gonna happen on that change. And that's why the therm is the most efficient on that way, because it's dynamically balancing the system by the temperature. Does that answer your question too, or?
Still a little confused on just big volumes. You don't need that much flow. Let's see.
Yeah, if you have one research line for one sink. And yeah. That's a big research, a 3/4 inch, probably even the sink is not a